Hey guys, so today what I'm going to teach you about is some basic chemistry, but it's very important because as you go on and you learn new stuff, everything will tie back to this basic topic. So what we're going to learn about is conversions from grams to moles. Okay, so and later on I'll talk about moles to grams, but for now let's stick with this. So the best way to understand this is to understand the topic of molar mass. Molar mass is when you go to the periodic table and, okay, so let's start off with an example of CO2. So to find molar mass, what you got to do is you got to go reference the periodic table. So look up the element of carbon. Carbon has a molar mass of 12.001, which is roughly about 12 grams, you can estimate. So O2. So basically what that means is there's two oxygens. So don't forget, you need to find the molar mass. Well, the molar mass of oxygen is the same. You just have to multiply it by 2. So it's 15.999, which is basically 16 grams estimate. So when you add them all together to get the molar mass of CO2, it is 44 grams. This key part is very, very important because as you see, when we go from grams to moles, you actually need the molar mass. Okay, so let's move on. Let's do another example. Let's do H2O. Let's find the molar mass of H2O. So, H, and O, that's what it's consisted of. So H has a molar mass of rounded to 1, and you need that twice. And oxygen, as we said before, is 16 grams. Ooh, grams on everything. So the total is 18 grams H2O. This is the molar mass. Now, molar mass never changes, okay? The molar mass of H2O will always be 18. And this is very important because as you see when we actually do a conversion that this molar mass never changes. So let's start off with a given number. Let's say in a problem it's asking you to convert 36 grams of H2O into moles. Now this is where you use the molar mass. So given the molar mass that we found with H2O, which is 18, notice if you reference back, we went back to the periodic table and we calculated, or you just looked off the periodic table and found the molar mass. So 36 grams. The whole point of this is to cancel out this grams H2O, and the top is always going to be 1 mole of H2O. So you're trying to cancel out this denominator with this right here to cancel out and get mole. So we have the molar mass, which is 18 grams. I'll put that right there, right? Grams H2O. These will cancel out, you see? And what you're left with is 36 over 18 moles H2O, because this what remains. This is basically just 2 moles of H2O, and that is your final answer. So quick recap here. What you did was you used what was given and notice how the given was in grams and they were asking you to convert to moles. So if it's given in grams, you know your denominator will most likely have to be in grams so you can cancel it out. And we use the molar mass here, which molar mass, the definition of molar mass is just how many grams in 1 mole. So that's the definition of molar mass. That's what that means. So that's exactly what you did. You were given a certain number of grams and you converted that to moles. Okay, now let's take another number, for instance. Let's take 9. Let's say the given number of grams was 9 grams H2O, and they want you to convert that to moles. Now, as I said before, molar mass never changes, okay? So for H2O, the molar mass will always be 18. So once again, 9 grams H2O. Notice the grams here. So most likely, or always, the denominator is going to have to cancel out. So it's going to have to be in grams. And 1 mole is equal to how many grams of H2O? Always. Universal number, 18 grams H2O. That never changes. Grams cancel out like that, and you're left with 9 over 18 moles H2O, and that's just 0.5 moles H2O. That's your final answer. Okay, let's go with a different a different element. Let's go for CO2. So let's find the molar mass of CO2 first. So CO2, it's consisted of carbon and 2 oxygens. So carbon is 12 grams. Oxygen, the 2 oxygens, 16 grams each. From the periodic table, this is all equal to 44 grams. So we know that 1 mole of CO2 is equal to 44 grams. This is the molar mass. So let's say a given number that you're given. Let's say it's 88 grams of CO2, and they want you to convert that into moles. Easy. So the given always comes first, and it's in grams, so you know the bottom also has to be in grams. So molar mass on the bottom, 44 grams, 1 mole. And grams to grams has to cancel out. Cancel, cancel. You're left with 88 over 44 equals 2 moles CO2. That is your final answer. Okay, I'm going to break it down again because this one's different than H2O. So what you did here is you found the molar mass. Reference the periodic table. You are not going to be able to find the molar mass without the periodic table. So individually, you find what each element has its own separate molar mass. You add them together, which we found was 44 in this case, right? So that means that there's 44 grams in 1 mole of CO2. But the given number is 88 grams. So we're trying to convert that into moles. And I'm just using easier numbers here, so you could probably figure out 88 divided by 44 is just 2, but you might not be lucky next time. The given number might be 50 grams. You have to do 50 grams and then plug it into that. Okay, actually, let's try that. So let's say the given number is 50 grams CO2. Convert to moles. So 50 grams of CO2, and the molar mass never changes, is 44 grams CO2, is 1 mole. Now this one's not all pretty and nice where it's just a 1-to-2 ratio or 2-to-1 ratio. This is 50 divided by 44 moles of CO2. So everyone pull out their calculator, and the calculator, you do 50 divided by 44. This is 1.136 or 1.14 moles CO2. Now this is what you will likely see on a test, because most likely your teacher won't be giving you these easy peasy numbers that have like an easy ratio, but just for the sake of learning the basics, this is important. So now we have a better example. Okay, so now let's talk about converting moles to grams. Okay, let me just scroll down for a sec. Okay, so we went from grams to moles. Let's go moles to grams. This is actually very similar. Okay, let's take, for instance, a given. You are given that there are, let's go with the 50. Let's say there are, okay, this is a very big number. Let's say there's 50 moles of, you want to do H2O? Let's do 50 moles of H2O, okay? 50 is a huge number, just putting that out there. Okay, so let's say there are 50 moles of H2O. Now, on the side, what did we say the molar mass was? So 2 H's both have a molar mass of 1. So 1 times 2 is 2. And you have the oxygen, which is 16. So the molar mass was 18 grams. 18 grams per 1 mole. So now you have 50 moles. So obviously the denominator is going to have to cancel out and you're going to be left with grams. So no matter this number always stays the same. It's per mole, per 1 mole. So you're going to have to match mole with mole. So it's going to be 1 mole of H2O this time. The mole on the bottom, so it cancel out, and the 18 grams. So if you look back to an example like this, what we did here is we did the moles and the grams on the bottom. But in this case, you're given moles. So you got to flip. So now it's moles on the bottom and grams on the top. So what you're going to be left with is grams. So you're going to cancel that out. And you have 50 times 18. You're not dividing this time. You're multiplying. And plug that in the calculator. That is, wow, big number, 900 grams of H2O. Very, very big number. And that is how you convert moles to grams. Let's do another one. Let's do an example. Again, moles to grams. Let's say you're given, let's say you're given 2 moles of NaCl. Okay, so our first step here would be find the molar mass of NaCl. That's our first step. So, NaCl. Na is around 23. Remember, reference back to your periodic table. And then we have Cl, chlorine, which is, okay, so it's around 35.5. So let's add those together. So 35.5 plus 23 is 58.5 grams NaCl per 1 mole. So in this case, the given number is 2 moles. So 2 moles NaCl. Okay, remember, bottom has to cancel out. So it's going to be per 1 mole NaCl. Then you plug in the molar mass, which we found 58.5 grams. Canceling out these moles down here. And what you're left with is 2 times 58.5 equals 117 grams NaCl, because grams is what you're left. That is your final answer. Okay, quick recap. Always remember when you're going from grams to moles, no matter what, grams to moles, moles to grams, always find the molar mass. And you can't find the molar mass unless you have a periodic table in front of you. You got to go to each element individually and add them all together. So what we did with CO2, carbon, 12 grams, oxygen, 16 grams. But there's 2 oxygens in CO2, so there's 2 pairs of 16. So the total is 44 grams. And once again, the denominators have to cancel out. So if you're given a number in grams, the denominator has to also be in grams. And it's always going to be 1 mole over the molar mass, or the molar mass over 1 mole. It's always how many grams per mole. 1 mole equals how many grams. And the same thing goes from moles to grams. You do the exact same thing. You're given the moles, you find the molar mass, and you multiply them. This time you're multiplying them because the bottom is canceling out. So the 1 mole is canceling out with the given number right here. 1 mole equals how many grams, and how many moles are you given? You cancel out the moles, and that's the number of grams you're given. That's it. And those are just called basic conversions. These are really important for chemistry, and I hope this video was good.